Fine furniture, musical instruments, functional art, beautiful decoration. These pieces, and others like them, are crafted in wood by master woodworkers who live here in Santa Cruz County and on the Central Coast. In this series, we meet some of these craftsmen and explore the paths they took to develop their talents. We will look at examples of their work. We'll discover what and who inspired them. Please join us as we enter their workshops and watch them demonstrate the skills and the techniques they use in creating their signature pieces. Hello and welcome to Woodworks. Today's program is a continuation of our instructional series, our how-to series. We've shown you so far how to make a trestle table, how to make a box, how to create a piece of inlay. Today we're joined by an old friend of Woodworks, Patrick Stafford, who, if you remember, is the head of the woodworking program here at Cabrillo College. Patrick is starting this year with his students, teaching them how to make a cabinet. So it's an ideal opportunity for us to come along and for Patrick to go through the various stages of joinery and show us some examples of cabinets that he's teaching his students to make. So let's get started. Over to Patrick. Patrick, could you walk us through what it is that you're going to be talking to us about today?
Well, I'm going to be talking about a very simple coopered cabinet with two coopered doors. We're going to be talking about a doweling and how the carcass of the cabinet, which is the cabinet itself, is put together, and how we're going to make the back of the cabinet and think about what's coming down the road later that we're going to talk about as far as the design of the cabinet and what we need to think as far as sequence, what we need to prepare for.
Out of interest, how long does it take the students to, how long does it take them to make a cabinet under your instruction?
It really depends on the student. You know, some of them, if they're here and they come in for open lab, they can make it in one semester. A lot of students have grandiose plans and they don't get started until late, and so they have to finish it on their own, or hopefully they can come back another semester. So here we have these three cabinets encompass quite a few different joinery techniques. We're going to be talking about doweling, which is how the carcasses are connected in the case of these cabinets, all three of these cabinets. And we're going to be talking about frame and panel. We're going to be talking about dovetails, mortise and tenon, dados. This one is actually a laminated piece that's been doweled through the bottom. You can see the ends of the dowels here. And what I did is I actually just drilled this on the drill press and then held that. I created a jig to hold this while I drilled into the laminate to attach the dowels. Now these pieces are all doweled, these carcasses. The dowels are in the end of these pieces that run into the top and bottom. When you're doing a doweling joint, you can't have a flush joint. So that's why how you can tell a cabinet's doweled is that the top and bottom extend past the side slightly. And the reason for that is because there needs to be some wood outside of the dowel to add strength. If the pieces were flush, the dowel would be too close to the end grain of this piece and would possibly pop out. Okay. So that's one of the ways you can tell a doweled carcass. Usually you've got the top needs to be slightly thick because the joint itself is dependent on the thickness of the top and bottom piece. The farther the dowel can extend in, the stronger the joint. This cabinet has coopered doors, and coopering is another technique I'll talk a little bit more about later. It has a frame and panel back, so this is a type of mortise and tenon, the frame and panel. It has dovetailed drawers. These are hand-cut dovetails. This piece next to it, this is a piece that's actually big leaf maple, which is a local tree. This piece has an apple wood panel, and it's a doweled carcass with a frame and panel door. And in this case, the panel is only held in at the top and bottom, so the live edge is just free to float. And it has a veneered back. So there's different types of back you can put in a cabinet. What you have to think about is the wood movement. So through the seasons, the wood's going to move back and forth. And in this case, I've got a veneered panel, which means I can glue it in the back and it will be safe from, it won't be moving because plywood is dimensionally stable, as opposed to the back in this one, whereas this is a solid wood panel which has to float in the frame, so it's not glued into the frame. If you look at the back, you'll see this is one of the things you have to think about when designing a cabinet is how it's going to look from the inside, and that's why this frame has a intermediate rail here. This intermediate rail, when you look at it from the front, sits on top of the shelf here, so the panel doesn't dive behind the shelf. So that's just a design element. It's not necessary for structure or strength. It has partitions, and these partitions have a loose spline that goes into the sides and into the top and bottom here. This piece has the same partitions at the top. There's a loose spline. So there's a dado in the shelf here, and the partitions fit down into that dado and up into the top. This has dovetailed drawers, and this cabinet, interestingly, I designed this cabinet and realized afterwards that you have to be able to take the drawers out to access them, because if this cabinet's hanging on the wall, you can't see what's in the drawers. At least at my height, you can't. Someone taller could probably look in there. This also has a shelf at the bottom that is hinged, so there's a compartment under the shelf. I raised that up so that this would be, whatever's sitting on the shelf would not fall behind, and you could still see it through the gap in the side. So yes, frame. It's a frame around it with the veneered panel. This is a cabinet that I'm working on with my students this semester. This is going to be a doweled carcass. This is a piece of deodar cedar that was given to me by one of our sculpture students here, which I just found that out yesterday. I've been assuming it was Monterey cypress as I've been working with it, but I'm noticing that it's much more aromatic. And that excites me because I grew up with deodar cedar in my yard as a kid, and it's from the Himalayas. It's a Himalayan tree, and it's actually used as an insect repellent there. So I realized that's why it's also used for incense, and they actually use deodar to panel their grain storage because it keeps the insect population down. So I've been noticing I've been sneezing a lot, and I'm realizing that that's probably what's going on here. So anyway, the piece of wood was given to me, and I was trying to decide what I wanted to do with it. So I started playing. I do a lot of my designing in PowerPoint. I use PowerPoint because it's a real cheap program and it's readily available, and I've got it on all my computers. So these are all done in PowerPoint, and I started designing the cabinet. Let me see. Well, I've got a bunch of different versions here. As I started out, the cabinet looked more like this in my mind. I don't know if you can see that, but it's a much wider cabinet. When I started cutting into the piece of wood, I discovered that that's not what it wanted to be. You know, it was not going to allow me to have doors that wide. I had to work around these flaws, these termite holes, and so this was as wide as I could make the cabinet. So I rescaled it down somewhat. What that leads me to is another design decision, because I'm kind of liking the idea of an asymmetrical cabinet. And so I've started playing with the idea of introducing a branch over here offset, because this looks so much like a tree to me. But I'm playing with that idea, and the way I design and the way I learned in school was I use a composing method of design, which means I do a rough sketch in the beginning and then change it as I build it. You know, a lot of times when you see things that are done from drawings, it's very static. They don't have a lot of soul, and that's because the people have been rigidly trying to force the wood into their will. And so if you allow the wood to design what it wants to be, I feel like it's a much more fluid process. So I've been playing with different ideas, and this is what it'll look like when it's open. The doors, it's going to have 3 drawers and a back panel. I have a detail of the joinery here, and this was more for my students to look at, but you can see the dowels in this case. And what I'll show you now is I'm going to take this apart and we can see how it's put together. These doors are coopered. That's how I get the curve. Now I start with a flat piece of wood, and then you cut it apart, and you glue it back, you make a slight bevel on each piece and then glue it back together, and it starts to form a curve. Now a cooper is a barrel maker, and coopering is used for making barrels. But here's another piece that I'm coopering. So this is a flat piece, and you can see where I cut it apart and then rejoined it at an angle. In this case, I actually set the joiner fence at 5 degrees. And you can change the curve by either making the pieces thinner or increasing the angle. So what I did here is I've got 2 wide pieces for a flat section in here, and then the narrower pieces with the increased angle. This is what we call an accelerated curve, which is much more interesting than just a radius. And so that's how these doors are made too, the same technique. So this is a book match. So these pieces were resawn out of the same piece to open up to give me that mirror image. And then they were cut. I didn't want to put any joinery in here because any joinery is going to disturb the pattern in the holes. So all my joinery is taking place over here. So there's just 1 big piece and 3 smaller pieces. I'm going to pull the back panel off. We'll talk about that more in a minute. I spoke about the intermediate rail earlier with the other cabinet. The reason for that is I'm going to have a drawer pocket down at the bottom here that's going to obscure the bottom rail. So I need this rail visually to complete the frame. This is a doweled carcass, and this is how it's put together. You can see the holes here in the top, and then the sides have the dowels coming out in this orientation. So what I've used is a doweling jig, which I've made out of a piece of mahogany. You usually want to make it out of a piece of hardwood. The reason this is so extra long and it's wider than I need to be is this way I know I won't put it in the wrong place the wrong time, okay? So when I'm drilling holes, I attach it with these finish screws so I can move it from place to place, but it lines up. It has a flat surface that's inside, and then it has a cleat on the back that lines up against the back of the cabinet. Since the back of the cabinet is my reference because it's flat, the sides are different width than the back and front, top and bottom, excuse me. This gets screwed onto the piece and drilled on the drill press. And these holes go almost all the way through. I leave about 1/8 of an inch at the bottom here. The farther I can get the dowels to go in, the stronger the joint. And the sides, and this is where it's easy to put it on backwards or sideways, is the cleat goes to the back side, and this surface represents the inside surface of the side, which lines up with the line that I've made on the top and bottom. If I make it the same size as the side, it's easy for me to put it on this way, which is going to be opposite what's going on here. It's actually, I could put it on this way so that, and got it all mixed up. Just 1 second. You got the idea anyway. Okay, you got the idea. Yeah, so now I'm getting those upside down. So this is doweled. Doweling is a great joint to use for a carcass, for a cabinet in this way. What's nice about it is you don't have to have flush corners, so you can actually have the top and bottom extend past, which gives you lots of options for doing a detail, which you can put a cove on it, depending on what kind of look you want. You can bullnose it like I did, well, on the one I showed you earlier. I'm going to turn this around. What I've done is I've got my dowels, and the reason I only put 2 dowels in is because I have to put this together and take it apart numerous times. If I keep doing that over and over again with all the dowels in, I'm going to loosen the joint. So I just put the 2 outside dowels in while I'm fitting everything. It will have, yes, there'll be 5 dowels per joint. Now what I've done here is I cut a rabbet in the back, and the rabbet that's a stop rabbet top and bottom, because I don't want it to go out the ends. And this eventually will be where the back panel will fit in. I can't cut the back panel to fit now. It just has to be the rough size. It's close, but not perfect, because I really don't want to final fit the panel until I've glued this cabinet up. okay? Because there may be some shifting happening. Depth of the rabbet is determined by how thick I'm going to have the panel be, truthfully. So this rabbet extends into the cabinet about a half an inch. This frame is going to be about 3/8 when I'm done, 3/8 thick. So it'll actually, there'll be about a 1/16 to an 1/8 of an inch of wood protruding behind the back. And that is part of the reason we do that is because most walls that you're going to hang this on are not flat. So that allows it to sit flat, sit better against the wall, okay? The joinery used here is the frame and panel. It's sometimes called a slip joint. Some people call it a bridle joint. It's a form of mortise and tenon. This is the mortise aspect. This is the tenon. And that slides in just like that. So that's how this is put together. It has a groove around the inside to receive the panel. The panel, it's a raised panel. So the panel is actually 2/3 the thickness of the frame. And it's raising towards the inside of the cabinet. So the back of the cabinet will have a flush surface, and the inside of the cabinet, the panel will come towards you. This is a book match panel that was made from the adjacent piece to the doors. This is the intermediate rail, which actually has a stub tenon on it that is the same size as the panel. And this just fits into the groove that I routed for the panel itself. This is the full tenon, and this is the stub tenon. We don't really need this tenon to be as strong as the tenons for the frame itself, because this is basically a cosmetic piece. It's not really for strength. And then there's the small panel that fits at the bottom. When you're clamping the doors, you can clamp the first pieces together quite easily, but as you're trying to clamp the last joint, it's going to want to pop up out of the clamps. And I tried every clamp in the shop here, all the fancy ones, and finally ended up going back to the pipe clamps, which are the ones I've had the best results with coopering. Just the funky old pipe clamps. But with this piece, I had to clamp it up in stages. You don't try to clamp it all at once. So what I did is I wanted to make sure and not save the middle joint for the end, because that's the one that's going to keep popping up. So I glued these together. I glued these together as a pair, and then I glued these to this and these to this. When I got to this point, it turned out that I needed to make a jig or a cradle so that I could clamp the pieces down and across so that I could get the joints to all come together without popping. For the concave side, I use a round bottom plane. So this is this plane has a very slight round, which will work in the flatter section. This plane has a more aggressive, a rounder round, I should say, that fits over in this area. And then this is a molding plane that has quite the round for finishing up this little tight joint right in here. These I made, this was the first plane I ever made, which I made before I was a student at the College of the Redwoods. And when I was at College of the Redwoods, if I ever wanted to make my benchmates laugh, I'd pull this out because they thought this was the silliest thing they'd ever seen. But I still use it, and it works well. And then this was one of the first ones I made up there. So plane making is, when I teach my classes here, it's the first thing we do, the first project, first day, is to learn how to make a hand plane. And so for the convex side of the panel, you can just use a standard flat plane. You don't need to make a convex plane. Yeah. I'm going to talk a little bit more about the doweling jig and the mistakes to watch out for. What I'm using are these trim head screws so that I can easily, it'll stay without moving while I'm doing all my operations. What I have here, of course you got to tighten the clamp. So the cleat lines up with the back of the cabinet, which is my baseline. The back of the cabinet is flush. The sides and the top and the bottom are different widths, so I have to reference off the back. What I do first is I actually figure out how I want to lay out my dowels. And to do that, I have to realize where my rabbet is going to be. I don't want my first dowel to be in the rabbet, so I need to move that forward. But I want to make it as close to the back as I can, because that's, of course, the strength of my joint. And if the joint's going to open up, it's going to open up at the front and the back. That's where the wood is moving the most. So you want to try and minimize the distance from the back. I have put the dowel so close to the back that I've routed into it with the rabbet, which is not the best, but it's not the end of the world if that happens. And then I put this dowel as far towards the front as I could. I had to decide the profile I was going to have on the side to receive the doors before I made that decision. And then I attached it to this piece of wood, and I actually went into the horizontal boring machine, which is essentially a drill press that drills horizontally, and I put it on and I pushed it in. I drilled through the jig and into my first piece at the same time, so I wasn't trying to drill the little piece of wood by itself. I drilled my 5 holes here. You could drill through this on the drill press to make the initial holes and then attach it to the side. The problem then is that it's hard to take a tall piece like this and put it on a drill press unless you have a floor model. So then you're stuck hand drilling these with a hand drill, and that's fine if you're good at holding the drill straight. So that is when it may be good to think about making your jig taller and out of maple or some really hard wood, so that it's always going to make you drill straight, so that you know that the drill press gave you a straight hole and that drill bit's going to follow that hole. Then you come and you remove it, and this is where it gets tricky, because I want to go to the other end. I can't take this and go like this with it, because if I flip it over, it's flush with the outside, not the inside. That tells me something's wrong. Okay, so that's why I always make my jig a little bit wider than my sides are thick. What I have to do here is take the screws out, flip the jig over like this, so that it's flush on the inside. Then I reattach and drill this side. So I do that on my 2 sides on the horizontal boring machine. Then I take my jig, and what I've done here is I've referenced where I want the sides to meet the top and bottom, and I've drawn a line. I drew this line with a square. I'm going to put the jig on with the cleat to the back, the inside surface against that line that I made. Okay? And then I will attach it with the screws, and I'll drill in here with the drill press so that I know I'm drilling straight. This is why it's really important to use a piece of hardwood for this, because of the subsequent drilling. If you're not exactly right on with the drill bit every time, it's going to ream the hole and they'll start moving around. And the important thing about this joint that makes it work is that it has to be totally accurate. If any of the dowels are off, it doesn't go together well. One other thing to remember when you're putting together, if your cabinet is going to have drawers inside, when you put your jig on, you line it up with your square line, put the first screw in, and again, you want to make sure your screws are not so long that they go through the bottom. Then I'm going to bump it over from the line towards the back, because for a drawer pocket, you want the sides of the cabinet to be slightly more opened in the back than in the front. And the reason for that is that when the drawer comes out, it starts to slow down as it comes out and doesn't fall out. If the drawer pocket is wider in the front than the back, the drawers will fall out. And it's just a 64th of an inch. It's a tiny, tiny amount. So you bump it over and put the other screw in and drill these. So that way I know that when I put the cabinet together, so that the front of the cabinet is tighter than the back of the cabinet. One thing I didn't mention was the use of the cabinet maker's triangle. or pyramid, depending on who you're talking to. But this is a great way of referencing your pieces. I've got it upside down. What I've done is I've made the sides of the pyramid on the sides, the top of the pyramid here, the bottom of the pyramid here. That keeps it so you always put your pieces back in the right order. What I used to do in the past was you'd put 1, 2, 3, 4, 1A, 2B, 3B. This is just a much quicker and easier way of referencing your pieces because there's no way of putting it back together in the wrong order. A twist drill, a standard twist drill, it's actually sharpened for drilling in metal. These are not really very good for drilling in wood. So what you do, they have spur bits which you can buy commercially, and they have a spur in the center, and then they have two little sharp wings, and they make a very clean cut. One of the reasons we need to do that is, well, there's two reasons. One is it gives a cleaner hole, but the other is that the same size drill bit will drill a bigger hole in end grain than it will in side grain. So you drill, for a 3/8 dowel, I drilled a 3/8 hole in the side grain, and the dowel will fit tightly. But if I drill a 3/8 hole in the end grain, it'll be loose. So what you do is you take the next drill size down, which is 31/64, and you regrind it and use that to drill the end grain.
And that concludes today's episode of Woodworks, How to Make a Cabinet. Thank you once again to Patrick Stafford, head of the woodworking program here at Cabrillo College. That was a really, really fascinating, interesting, and valuable lesson for us, Patrick. Thank you. And I hope everybody out there is now inspired to go out and try their cabinet making skills and perhaps come up with something as beautiful as the cabinet that sits now between Patrick and myself, which I know has a history. And it's an interesting history, Patrick. Tell us a bit about it.
Well, this is the first cabinet I made as a student at College of the Redwoods. And I labored and sweated over this for at least 2 months, maybe 3. And part of the reason I was sweating so much is because James Krenoff was there watching me build it, and he was helping me design it. That said, I think it was a successful cabinet, and he actually ended up really liking this piece, possibly because I copied his handles in the door here. And this is all the same techniques that we just covered. And, you know, it was a real pleasure to make. And I would say go forth and have fun.
So thanks once again, everybody, for watching. Join us again next time. Goodbye.